It's just, I can't afford to lose another day. It's just life. Okay, variations. Variations. For some reason, students stumble some over variations. But to be quite honest, they're a simplified form of linear functions. So, a couple things. First, the first kind of variation is direct variation. Direct variation. Variations involve a constant, and the constant corresponds to the slope. All right, so here's the thought if you can wrap your brain around this. If we had the equation of a line where the y-intercept was 0, would we write the plus 0? We wouldn't write it, right? It would be y equals mx, and that would be it. Would you agree? Because again, it'd be plus 0, and why would we write plus 0? Well, that's what direct variations are. The y-intercept is 0. So we don't even write it. And all you're left with is y equals mx. The only difference is, for some reason, they want to confuse students. So instead of using m, we want to use k, the constant of proportionality. But it's the same thing as the slope. It's the exact same thing. And there's two different ways you can look at the equation. You can look at it as y equals the constant times the x, or you could look at it as the constant equals the y divided by the x. It's the same thing. Right? The second situation is solving the equation for k, right? Put the x on the bottom across the equal sign. They're one and the same. Okay? So really, if it were me, I would just focus on y equals kx. If you know that, you can do everything. You got one less thing you got to remember. If they ask you for k, you stick in y, you stick in x, divide y by x. Not a big deal. All right. K is the constant of variation, or some say the constant of proportionality. So K is a constant. K is a number. 7, 11, 3/5, 3.1416, etc. 2.71828, etc. It's some number. It's a constant. All right. So when we talk about direct variation, it is said that x and y vary directly or are directly proportional. When the situation is y equals kx, they vary directly or they're directly proportional. So the graph of the line, the graph is a line through the origin. I've mentioned that to you already, right? The y-intercept is 0. And again, the k is where the slope is, so the slope equals k, right? The constant of proportionality is the slope. All right, this is something that you need to be aware of and you need to keep track of. And that is this aspect. With direct proportion, so let me go a little higher here, underneath D. As the x increases, because they're directly proportional, the y increases. They go in the same direction. If you increase x, you will increase y. Which means if you can picture this, thinking about domains, thinking about x values, as you move from left to right, doesn't that increase the x? As you move from left to right, aren't our x's getting bigger? So what's happening to the output, the y? It's going up, right? So it's going up from left to right. Okay, right, Destiny? Late night last night? All right, and so same thing the other way. If you decrease x, then you'll decrease y. They are directly proportional. Directly proportional. So I know it's small, but got a little graph here off to the right. And the equation of this direct variation would be y equals 2x. You should recognize a direct variation. Again, it's going to start at the origin. and it's going to be a positive slope. It starts at the origin, it's a positive slope, it's directly proportional. Increase x, increase y, decrease x. Decrease y, what's the value of k? The value of the slope. How do you figure out the slope? Find any two clear points, do the vertical change over the horizontal change, right? Or you could pick any point and divide the y by the x. You'll get the same thing, same situation. All right, how do you solve direct variations? Or again, direct proportions. It depends on who's saying it, which way you'll hear it. All right, you can solve them two ways. You can solve them by finding k, and then once you know k, use the information from k to then get the value you're after. That's a two-step situation. So first you find k, then once you know k, you use k to get the information you want. It's two steps. The other way is by using a proportion. By using a proportion. For direct variation, it's x sub 1 divided by y sub 1, or the initial x divided by the initial y, divided by x sub 2, or the final x, divided by the final y. That's the proportion. And remember, with the proportion, right, you can flip them as long as you flip both. If you wanted to, you could do y1 over x1 equals y2 over x2, right? You flip both, and you can solve it as a proportion. I'll do the first one both ways, but I think the proportion is a better way because it's a one-step situation. All right, so here's the problem. If y varies directly with x, if Alex traveled in the snow 100 miles in 7 hours, how long would it take for him to go 140 miles? All right, stray comma there. Extraneous comma. Pretty simplistic problem. And again, listen, we give you things in the beginning with a simplistic nature to try to teach you the concept and what to do so you're not confused. So don't bypass the whole procedure by simply just figuring it out in your head. Oh, I can just figure it out in my head. Okay, great, but we use an easy thing so we can show you the procedure. All right, so in the first situation, you're going to find k, and so you know k equals y over x. Say, Mr. Scarfi, how did we know k equals y over x? Because up here it says k equals y over x. All right. And again, if you don't think of it that way and you think of it y equals kx, fine. You can do it that way as well, solve it that way. So what is k? What is y? And you got to decide what is x and what is y. That's up to you, what you want to figure, what is x and what is y. I'm going 7 over 100. You can do it the other way if you want. Knock yourself out. Say, what if I went 100 over 7? It'll come out in the wash. And you got to switch the other things and you'll still end up in the right place. Okay? So if you say, well, I didn't know to make the x to 7, I would have made the x to 100. It'll work. You'll still be solving for the other variable. You'll be fine. So again, in this way, how do you finish then? Then I'm going to do y sub 2 equals k x sub 2. Y sub 2 equals k x sub 2. So in my situation, I made x the time and I made y the miles. Agreed? If you do it the other way, you'll just switch them. And instead of solving for y, you'd solve for x. You'll get the same thing. You'll end up in the same place. Do you understand the x and the y's are just labels that we're coming up with anyhow? It's not a big deal. All right. Now, if you don't, it doesn't matter. It really doesn't matter. So 7 over 100 times, what are we going, 140 miles? And if you include your units here, so miles and miles, you'll see your miles are gone. And you're left in hours, which is what you want, because we are trying to figure out how long. So again, because I did 7 over 100, I'm solving for y. If you would do 100 over 7, that's fine. You'll solve for x. Me, I'm going to multiply to finish. If you did it the other way, you'd be dividing by k, right? The 7 over 100. And so when you multiply that out, what do you get? 9.8 hours. Hey, we're doing hours. Does anybody talk in terms of like, yes, I was traveling 35 hours, right? We don't talk like that, so 9.8 hours. If you want to knock yourself out and figure out the minutes, go ahead and knock yourself out. Right, 0.8 times 60, right? The decimal remainder times 60 minutes would give you how many minutes there were. Okay, so that's the find K, use K to figure out the second value. You can do the same thing with a proportion. Just to keep from confusing you, I'll follow the exact same format here. So I'm not going to rewrite it, right? We're just going to use this proportion. So if I use that same scenario, so I did X as 100 miles, Y as 7 hours. Okay, so we got to go all the way back to pre-algebra, then algebra 1. Right. The only thing with proportions is if you get them twisted, they won't work. So you got to things have to correspond. So that's why I like to put the units in, because the units help me to get the things in the right spot. So I use the 100, I use the 7. The only thing left is 140 miles. And it's either going to go in the top right or the bottom right. So it goes in the top right because the miles are in the top. Right? I mean, miles are in the top. So it's going to go in the top right. That has to correspond. If they would have given me hours instead of miles, I'd have put the hours in the bottom right and found the top. And so then what? Y sub 2 is down at the bottom. Right. Again, proportions are really easy to finish. Things on the top go to the bottom across the equal sign. Things on the bottom go to the top. Do you ever want to solve for the variable in the denominator? And your answer should be no. So first thing you want to do is get your variable in the top. You got to get your variable in the top. Okay, we got rid of it. We moved it. Same thing as multiplying both sides by y sub 2. Now let's move the 100 miles. It's on the top. It goes to the bottom across the equal sign. All right. Let's move the 7 hours. It's on the bottom, so it goes to the top across the equal sign. Notice how your units also help you at this point to figure out if you made a mistake. Because miles are gone, and I'm left in hours exactly the way it ought to be. Look, if you get to this point and you're left with something over hours, you got a problem because your hours are in the bottom. If you get to this point and your answer is in miles, you got a problem because we're looking for hours. And go back and say I made a mistake. Something's wrong. The issue is sometimes a lot of you don't bother to use the units, and therefore then you'll never know if you're off. All right, so you end up then 140 times 7 divided by 100, and guess what? It's still 9.8 hours. So you can do it either way, whichever way your brain works the best. If your brain works better, hey, let me get K and then use K to get the other one. Then do it that way. If your brain works best for proportion, then do the proportion. Whichever way your brain works, then do it that way. All right, this second one has a twist here, and I want to get higher, so I'm going to get rid of my screen. So the second question, if y varies directly with x, if a hydraulic ram can exert 362 pounds per every 3 inches squared, how much total force can it exert over 1 square foot? Anybody notice anything unique to this problem? Luke? Yeah, our units don't match. That's an issue. And when units don't match, you got to change one of them to the other, otherwise you're going to be in trouble. Right? We have inches squared and we have feet squared. That's not going to work. So we either need to convert feet squared into inches squared or inches squared into feet squared. And I gave you a little graphic to help you because people can't wrap their brain around how many square inches are there in a square foot. they usually want to say 12. And there's not 12 square inches in a square foot, right? Or do you think there are? Remember, it's foot squared. It's foot times foot. So it's really 12 times 12. There's 144 square inches in a square foot. And that's what the block here illustrates, right? Look, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 inches, right? But again, you go up 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you see how there's 12 rows of 12 inches for a total of 144 square inches? All right, be careful. So, Mr. Scarfi, I would have never thought of that. I know, that's why I'm mentioning it now. All right, beware of your units, though. You got to match. Once you're done with that, then we're just going to decide, hey, do I want to do a proportion? Do I want to use K? I like the proportion. I'm going proportion. And the other thing is, I always like to put what I'm solving for on the top left of my proportion. Remember, you can write the proportion any way you want. So what's the question? How much total force can it exert over 144 square inches? Now look, if you want to go X and Y, knock yourself out, I'm just going to go F, because it's a force. You can do X and Y, have fun. It's not a big deal. But here's the point. The force I'm looking for goes with what? It goes with the 144 inches squared. And I just always make them the same fraction. Now all I got to do is fill in the other side. Force is on the top. What of the given information is a force? The 362 pounds, right? That's a force. You didn't know that. It is. Some of you right now are exerting approximately 100 pounds of force on your chair. Others of us would be exerting a little bit more. All right. But that's the reality. It's a force. And then on the bottom, again, notice how the units are matching. 3 square inches, right? So again, whenever you make your proportion with your variable in the top left, it's only one thing you got to move and you're done. And that's why whenever I'm setting up the proportion, I always put what I'm looking for in the top left. It's a one simple step thing. Things on the bottom, go to the top, cross the equal sign, and oh, by the way, my inches squared divide out. If you wouldn't have known to change inches, feet squared to inches squared, right now having your units in, you'd say to yourself, self, I have a problem. My units don't match. Of course, again, a lot of you don't bother putting your units in. And next year when you get to physics, oh well. So might as well learn it now. Use your units, they'll help you out. All right, so that's the situation. So what do we end up with? Anybody got it? 376 pounds. Hydraulics are a wonderful thing. They can exert a lot of force. I don't know if you've ever used a hydraulic jack to jack up a car or anything like that. You're given your whatever force you can do, and you're jacking up a 3,000-pound car. Amazing, right? Hydraulics, mechanical advantage, physics. Awesome. All right. The period, capital T, of a pendulum varies directly with the square root of the length of the string. That's a L. If the period is 4.3 seconds when the length is 80 centimeters, what length will result in a period of 7 seconds? It's just a proportion problem. It's directly proportional. It's a direct proportion. We can either use y equals kx and solve for k, or we can use a proportion. I like the proportion. You don't have to worry what's k and what's x and what's y. So where would I put, what am I looking for? What length will result? So I'm going to do L of F, the final length. Pretty simplistic. What measure of everything said goes with our final length? There's three other things, right? 4.3 seconds, 80 centimeters, and 7.0 seconds. Which one goes with this length, the final length? Which one goes with it? 7. So that's what goes on the bottom. All right? And again, I'm putting my units there because help me know where to put stuff. All right, now the other information is the other side. Length is, length is 80 centimeters. And the other time is 4.3 seconds. Again, if you put your variable top left, pretty simplistic move. So I'm going to move to 7.0 seconds. My seconds divide out. I'm a happy camper. I break out my calculator. 80 times 7 divided by 4.3. And if you're worried about significant figures being our times to one decimal place, hopefully 80 is exact, whatever. How about 130.2 centimeters? That's how long that would have to be for a longer time. Does that make sense? Think about the pendulum. Look, the pendulum, one period of the pendulum is one, do it this way. Let's say this was the max height. The time for it to go here and back, one cycle, is the period. Well, if it's longer, won't it take longer to swing there and back? It would. And your answer even makes sense. Questions? Let's go to the next page. All right, so that's direct variation. Well, there's also inverse or indirect variation. Some say indirect, some say inverse. I'll say indirect right now. Same thing as inverse. Indirect or inverse variation or inversely proportional. Okay, so we're similar to a degree, but instead of y equaling kx, now it's y equals k over x. So in this case, k would equal yx, right? Or xy, whichever way you want to write it, doesn't really matter. Okay, so you got to recognize that. You can already notice the graph I have up there. What do we have here? We've got a decay, right? And that's the situation. Are inverse proportions linear? No, they are not. By the way, what have we been graphing? Inverse functions, right? Where's the x variable? In the denominator. X equals 0 would be an asymptote, right? So that's what's going on. All right, so again, k is still the constant of variation or the constant of proportionality. And again, you're going to say x and y vary inversely or indirectly and are inversely proportional or indirectly proportional. Depends on who's talking, which way they say it. So inversely or inversely proportional or indirectly and indirectly proportional. Same thing. All right. Commonly, the graph is a, by the way, what was the name of that shape? I think I've only said it a couple times. Hyperbola. 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 Awesome. All right, so inversely proportional. So direct, increase x, increase y. Decrease x, decrease y. So it stands to reason inversely. If you increase x, you're going to decrease y. And look at the graph, right? As x gets bigger, moving from left to right, what's happening to y? It's getting smaller. They're inversely proportional. One goes one way, the other goes the other way. If you decrease x, you're going to increase y. That's the point. And look, if you can't take anything away from this lesson, you definitely need to take away for the rest of your life directly proportional, increase one, increase the other, decrease one, decrease the other. Inversely proportional, increase one, decrease the other, decrease one, increase the other. That you definitely got to take away. That's knowledge every person should have, apart from all the other math and stuff. Inversely proportional, go the same way, or directly proportional, go the same way. Inversely, go opposite. All right, you can solve them two ways again. Same situation. You can do it by solving or finding k and then doing the equation again. Or you can do a proportion. Now look at the proportion this time. Well, it's really an equation. Because for inversely proportional, it's x1, y1 equals, what would you expect? X sub 2, y sub 2. So that's kind of that's my preferred way. But you can do it either way. Again, if your mind is better, hey, let me find k, and then I can use k and figure out x or y, then fine, do it that way. I just like using the one-step equation. But whichever way your mind works better, then go that route. Okay, so here's a situation. If pressure varies inversely with the volume of a gas, and it does, and the initial volume is 112 milliliters, when the pressure is 780 milligrams of what? Come on, science. Milligrams of mercury. You had that. Find the volume if the pressure is increased to 800 milligrams of mercury. All right, so we're going to increase the pressure. So, here's what we've got. I'm going to use my red here. Initial volume. How about like V sub 1? The initial volume. When the pressure is 780, how about P sub 1? Initial pressure, initial volume. Make sense? Find the volume, V sub 2. Some like to go I and F, initial, final. Some like 1 and 2. Whichever floats your boat. Is increased to, and our pressure to is 800 milligrams of mercury. All right, here's a formula. It goes along with Boyle's law. Boyle's? Charles? Boyle's law. All right, again, I like solving with the variable on the left. So you know what I'm going to do? Because I'm looking for P sub 2, I'm going to go P2 V2 equals P1 V1. I just swap sides. It doesn't matter. You can do it the other way. Keep it P1 V1 equals P2 V2. By the way, you guys know the combined gas law? P1 V1 over T1 equals P2 V2 over T2? No? All right. It's a story for another day. All right, so I'm looking for P sub 2. What is volume 2? Volume 2 is, that's what I'm looking for. Oh, my bad. P2. P sub 2 is 800 milliliters of mercury times V sub 2. Just subbing in now, right? Subbing in. What's our initial pressure? 780 millimeters of mercury. What was our initial volume? 112 milliliters. Again, I always include my units. They'll tell me what my final units answer are. All I do is put in P2 V2, P1 V1. Easy to solve, right? You're just going to divide by the 800 millimeters of mercury. And oh, those units divide out. And we're in milliliters. Hunter.
Shouldn't it be P1? Shouldn't it be 780 milliliters of mercury instead of millimeters?
Of course it is. And you know what? It is millimeters, not milliliters. Yeah, it's actually millimeters. That should be an M, not an L. Right there. So typo on the initial problem. It's millimeters of mercury. It could be inches of mercury is the English standard. Metric is millimeters of mercury. Volume is a milliliter. So liters volume, millimeters of mercury is pressure. PSI, pounds per square inch, pressure as well. Atmospheres, pressure, a bunch of different pressure situations. Okay, so you just punch the numbers now, right? Just punch it out. You know you're going to end up in milliliters, and I think we end up with 109.2 milliliters. So let's think about the proportion. Again, you're just going to do 780 times 112 divided by 800. So what happened to our pressure? P1, our pressure was 780, and it became 800. So pressure went up, and therefore our volume was 112, and now it's 109. It went down. Pressure went up, volume went down. Think about a gas. The more pressure you exert on it, you constrict it to a smaller volume. And that's what pressure is all about. All right, anyhow, a little science sprinkled in. Number three. You can have a joint variation. So you can have more than one variation going on at one time. So a couple examples. If y varies directly with x and z, so it's going to do directly with both. All right, directly is when they're on the same line. Whoops, that's a z, second one. So k, the constant, and then the x and the z, directly with both. All right. Again, you go back and look at direct variation, y equals kx, constant, the x, and then the other one, the z. They're both direct. Second scenario, y varies directly with z and inversely with x. Would you agree with this? Kz directly with z, but inversely with x. Right? Inversely, top and bottom, right? Different ways. Directly, same level. Directly, up, up, down, down. Directly, same level. Inversely, up, down, up, one high, one low. If you just think that, you'll get them right. All right, let's do one last problem. The number of moles, you guys know what moles are? Not the things in my lawn that are driving me crazy. Joanna, you see my lawn? It's all the moles. I need a cat. I need to borrow a cat or a dog. I need to borrow a dog. All right, anyhow. A mole is a unit of measure. Moles, 6.023 times 10 to the 23rd, right? That's the amount. Right, Mr. B, a mole? 6.023 times 10 to the 23rd?
6.022, but...
Oh, okay. Well, yeah, potato. All right, so the number of moles of a gas N. You need somebody, sir?
I do. Can I have her?
Absolutely. The number of moles of a gas N is directly proportional to the product of the pressure and volume, and inversely to the temperature. So we're going to write this. Number of moles is N. It's directly proportional. All right, we need a K, right? Because it's a proportion. Directly proportional to the, I'm going to use some color here, pressure I'm going to put as a P. Directly with pressure. Directly with volume. Does the volume go top or bottom? Directly, right, top. And inversely with the temperature. So the temperature's got to go in the bottom. Now that's not the normal form of this. If you were to solve this, this is how this would end up. PV equals N, and instead of K, they use R as the constant. PV equals nRT, which that's a big formula in physics and figuring out relationships between pressure, volume, and temperature of an ideal gas. PV equals nRT. Luke.
Will K always be on top?
K, the constant, is always on top. Yes, because, look, I don't know if you caught it, Luke. But technically, if I put K on the other side, it's on the bottom. But guess what? If K were 3, it's a constant. If it's 1 over 3, it's still a constant. It's just third, so it doesn't matter. So you just write it on top. K is always on top, though it could be like a 1/3. But K is K. I don't know if that answered your question, but that's it. All right. Do your homework tonight so you don't have any Friday, Saturday, Sunday, Monday. Test on Wednesday. I'll be around after school if you need some help.